All right, so let's go ahead and take a look at solving systems by graphing. Now, I gotta tell you, the only reason why I really did this section for you guys, or had you guys work on this section, is because I thought that you guys really needed some more practice with graphing. In the end, when you solve systems of equations, I never want you to solve them by graphing. I just thought it would be a really good opportunity for us to do things by graphing. So I'm not going to do a whole lot of these questions. You know, I don't want to spend a whole lot of time doing them, because mainly what I wanted you guys to do was just to get a few more questions done with graphing. Okay. So typically when you solve systems by graphing, you have two equations, two variables, and then what you're trying to do is you're trying to find the solution. So the solution is where the two graphs intersect, which typically we do this by solving them algebraically, either by substitution or by elimination. We rarely use graphing to solve them because it's kind of just a pain. But okay, so let's take a look at some graphing. So I wanted to take a look at something like question 5 here. So let's divide both sides by 3. So then I get y is equal to negative 2x minus 1. So when I graph this here, my graph is all slanty. I graph my top one, so that's at negative 1. And I go down 2 and to the right 1. And so my graph, looks something like this. And then I start at negative 1 again, and I go up 2 and to the right 1. And so my intersection is pretty clear. It is the y-intercept of both of those equations, which is 0, negative 1. Now, if I was totally like randomly guessing what the intersection was, then I would guess, right? And then I'd take this value and I would plug it into both equations, and that's why I said it's kind of a pain, because I would plug it into both equations and make sure that it actually worked. Like it gave me like 0 is equal to 0 or 4 is equal to 4. And so that's why it's kind of a pain, because if you mess up your graphing, then you don't actually have the right values, and then you're kind of all messed up. Okay, so that is solving systems by graphing. We will do elimination and substitution, but I do want to just, do a little bit of practice here with graphing these equations. So let's go ahead and let's do, I don't know, let's do 1 and 2. And maybe we can try 4. I think 4 might be a little weird though. Okay, so try 1, 2, and 4, and then we will come back and look at those graphs. Okay, so we're back. And I'm going to graph negative 4, and I'm up 1 over 1. So my graph looks like this, and then I'm at negative 4 again, and I go up 2, 3, and then over 1. And then my intersection is the y-intercept, so that is 0, negative 4. But that's pretty clear. Okay, and then we'll do this one, up at 1, down 2 over 1. And then we're at negative 2, and we're up 1 over 1. So we're here, and then we are here. And that one's also pretty clear, positive 1, negative 1 is my intersection between the two. All right, now this one is the one where if I mess up my graphing, we may not be able to tell what my intersection point is. Okay, so let's go up 3, up 1 over 1. Okay, and then we're at negative 2, down 1, 2, 3, 4 over 1. So maybe like a little off. It should have been more like this way. So maybe, yeah, it is pretty close this time, because I did solve it algebraically. negative 1 comma 2. So then I would plug this in. So is 2 equal to negative 1 plus 3? Yes. And then is 2 equal to negative 4 times negative 1 minus 2? And then the answer is also yes. So my solution is negative 1 comma 2. Okay? All right, and that is it for this section.